Hi everybody, this is Jim Corkins, and what we're going to do today is we're going to talk about 1.1.1 lecture tutorial. So you've done week 1 and you're now here in week 2, and you've got all the way through this content, and you're now at 1.1.1 motion tutorial. You've clicked on this, you've downloaded this tutorial right here, and you've opened it up. And now we're going to go ahead and edit this tutorial like you would edit any Adobe file. But what we're going to do real quick is just a real quick talk about the different types of motion. So in this tutorial, they talk about a velocity versus time graph. So this tutorial is to teach you velocity versus time graph and how slow and fast velocities look on a velocity versus time graph, and what a rightward velocity and a leftward velocity look like on a velocity versus time graph. We're also going to talk about objects at rest. Okay, so that's another type of motion. So all 5 of these types of motion you kind of have to know. So let's do a real quick summary. And again, just for the sake of understanding this, all of this can be found in 1.1.1 lecture on velocity versus time graphs. Okay? So let's go ahead and talk about these different types of motion. So the first thing I'm going to do, so here is a basic velocity versus time graph. I'm going to label this. I like making things concrete, so this time is 0 seconds, so 0 seconds, and then there's like maybe 1 second, and then there's 2 seconds here right at the end. So this is the t-axis. Okay, now the vertical axis is the velocities. 0 meters per second is right here. This will be the positive 1 meter per second velocity, and this will be the actually let's call that let me do this, let's call this positive 2 meters per second, and then positive 4 meters per second. Okay, on the other side of this you have a negative 2 meters per second and a negative 4 meters per second, right? So I'm numbering this kind of like we do a position versus time graph, where if an object had negative positions and positive positions, except that when we're talking about velocity, these velocities right here represent velocities moving to the right. And that's the reason why they're positive. Positive velocities mean the velocity vector is directed to the right. These velocities right here in this range are directed to the left. So any lines appearing down in this region are lines appearing to the left. Okay? All right. So let's go ahead and talk about what would it be like, what would a velocity versus time graph look like if we're representing an object not moving? Well, if an object is not moving, it has a velocity of 0. And if it's got a constant velocity, it means it's not speeding up or slowing down, but it's got a velocity of 0 the entire time. It's going to have a velocity of 0 meters per second at 0 seconds. And then at 1 second, it's going to have a velocity of 0 meters per second. 2 seconds, a velocity of 0 meters per second. 3 seconds, velocity of 0 meters per second, and so forth. So basically, this is going to look like a velocity line at the horizontal axis, and that represents not moving. So that is what a velocity looks like for an object that is at rest or not moving. Okay. Now, part of your tutorial is asking for what does a slow object moving to the right look like on a velocity versus time graph? So I'm going to use purple. So a slow object moving to the right, so we could all agree that an object moving at 2 meters per second is slower than 4 meters per second, okay? So an object moving slowly, and I'm going to say 2 meters per second, it's going to be moving slow that entire time, just like down here. So at 0 seconds, the object is moving at a constant velocity of positive 2 meters per second. 1 second later, it's moving to the right at 2 meters per second. And at the second second it's still moving to the right at 2 meters per second. So it's got a positive 2 meters per second velocity the entire time. So this is what I would call slow velocity to the right. Okay. Similarly, if an object is moving fast, and I'm going to use green for fast, well, 4 meters per second is greater than 2 meters per second. So you'll also notice that if an object is moving fast, it's further away from this 0 meters per second, okay, in either direction. So fast moving to the right is going to look like positive 4 meters per second at 0 seconds, positive 4 meters per second at the 1 second, positive 4 meters per second at the second. So this looks like a constant velocity that is fast. This is fast velocity to the right. Okay, so above the 0 line, any lines above the 0 line, those are lines moving to the right. And if the line is further away from that horizontal axis, that means it's traveling faster. Okay, again, purple in my case represents slow. If an object is moving to the left and slow, well, it's got a negative 2 meters per second at 0 seconds. It's traveling at negative 2 meters per second at the 1 second mark. And then it's still traveling to the left at 2 meters per second at the second. So that means it's traveling to the left the entire time. So it's a line below that horizontal axis. And it's in the negative portion of the graph that represents leftward velocities. Okay? So this is slow velocity to the left. If an object is traveling faster while moving to the left, and we're going to call 4 meters per second greater than 2 meters per second, again, it's further away from that 0, that horizontal axis. An object is traveling at negative 4 meters per second at 0 seconds. It's still traveling to the left at 4 meters per second at 1 second. And at the second seconds mark, it's still traveling to the left at 4 meters per second. So this represents fast velocity to the left. Okay? And so I hope you learned a little bit about this. What I'd like to also do is do one of your tutorial questions, okay? So here we go. Let's do one of your more complicated tutorial questions. Let's do E together, okay? So I'm going to zoom in on E, and E has 3 different types of motion. So here's how to approach a tutorial that has 3 different types of motion. So what I'm going to do is I'm going to go to the drawing part, and I'm going to draw, and I'm going to number this velocity versus time graph just like I numbered this little this guy with the 4s and the 0, 1, 2, 3, except now I'm going to use 3 seconds because there's 3 different types of motion. I'm going to represent the time in terms of 3 seconds. So this is 0 seconds, 1 second, so 0, 1 second, 2 seconds, and then finally 3 seconds at the end. So this will be the fast first part, and that's from 0 to 1 second. The at rest is going to happen 1 to 2 seconds. And then from 2 seconds to 3 seconds, I'm going to represent this type of motion. Again, you don't have to do this, but I'm doing it because it makes more sense for me. This is the 0 meters per second. This is positive 2 meters per second. This is the positive 4 meters per second. Negative 2 meters per second. Negative 4 meters per second. Okay, so on the other graph, so once I've got that set, now I'm going to go ahead and approach it. A fast constant speed to the right. So I can use what I've learned here, and I'm going to combine the different types of motion. So fast, I think we used green, so I'm going to use green. And if it's to the right, that's going to be in the positive direction, so it's going to be up here. And for that first second, it's traveling to the right at positive 4 meters per second. Now, what's going to happen is we represented not moving as red in that last, in the Microsoft whiteboard. So now, at the 1 second mark to 2 second mark, it's standing still. Okay, and then in the at E right here, we have an object moving at slow constant speed to the right. So slow, I think we use purple, and that looks purple. And so from 2 to 3 seconds, it's moving at a positive 2 meters per second for that last second. Now you don't have to connect the lines, but a lot of people like to do that. So you could say connect these lines as all different types of motion. You don't have to do that. You could just represent it as those 3 different types of velocities. Okay, so please try this out. Take your time, try to learn as much as you can. Okay, and I hope everybody had a wonderful day.